Hi, we are Cecilia, Erica, Jamera, Kate, and Shanna, and for our project, we are doing Letterboxd Reviews Sentiment Analysis. So Letterboxd is an online platform where users rate and review films, providing rich text data for studying audience sentiment. Movie reviews present unique challenges for sentiment analysis because they often contain sarcasm, exaggeration, and irony, adding complexity that can cause models to misinterpret the relationship between review text and star ratings. Previous research on film review data shows strong connections between the text of a review and the movie's numerical star rating. In the context we want to study, we use Vader, which is a Python-based sentiment analysis model that uses lexicon and rules to assign sentiment scores, to find the correlation between text review and numerical star rating. So our research question. Sentiment analysis tools claim to quantify emotion from text. However, platforms like Letterboxd don't always follow literal word patterns. Users may use sarcasm, tone, and voice subjectively. So the key question is, does Vader's sentiment score actually align with star ratings on Letterboxd? We tested whether a popular sentiment tool can reliably interpret real user reviews to see if the Letterboxd star rating is accurate to the sentiment analysis score. And so our hypothesis is that we predict that the sentiment polarity of Letterboxd movie reviews, as measured by Vader compound scores, will show a positive correlation with the star ratings assigned by users. However, we expect this relationship to be statistically significant but moderate in strength, as Vader may struggle to fully capture the sarcasm, ambiguity, and mixed emotions common in Letterboxd reviews. So for our data, the reliable variables we used was the review, the rating, and the title of movie watched. The review allows us to qualitatively understand what each individual thought about the movie, and the rating is on a simple 5-star system in which the user can quantify their opinions on each film. Lastly, the movie variable represents the movie watched by the users. We got our data from Kaggle, and these are our two links to both of our datasets that we used and combined, which was Letterboxd movie reviews with the top 250 movies and the worst 250 movies. We explored our data, and here are some figures that demonstrate the results. Figure 1 is a histogram that displays the distribution of Letterboxd star ratings. The data reveals a bimodal distribution, with the highest concentration of reviews occurring at 1 or 5 stars, suggesting that users tend to review movies they feel strongly about, whether it be positively or negatively. Figure 2 displays a distribution of mean standardized Vader sentiment scores by star ratings. The bar chart demonstrates a clear positive relationship between star ratings and Vader scores, with a generally upward trend as ratings increase. Reviews with 0.5 stars exhibit the most negative mean sentiment, while 5-star reviews show the most positive mean sentiment. Figure 3 shows the variability of standardized Vader within each star rating. The box plot also confirms the positive relationship between star ratings and Vader sentiment, but there is a high variance within each category, especially for reviews rated between 2 and 3.5 stars. Therefore, the relationship is more moderate rather than strong. For our analysis, we begin by measuring the statistical relationship between Vader sentiment scores and Letterboxd star ratings using Pearson and Spearman correlations. Both were around 0.36, indicating a statistically significant but moderately positive relationship. This means sentiment generally increases as star ratings increase, but the relationship is not strong. Next, we built a baseline linear regression model to predict star ratings from sentiment. While the regression line shows a positive trend, the residual plot and the low R-squared of 0.135 makes it clear that sentiment alone does not explain much of the variation in star ratings. The model fits the direction of the trend, but performs poorly overall. To improve performance, we use logistic regression with grid search CV for hyperparameter tuning. This model achieved 53% accuracy with around 60% precision and recall for positive and negative reviews. However, it performed poorly on neutral reviews, confirming that Vader struggles with nuanced or ambiguous sentiment. Other models like Random Forest or XGBoost may help, but the core limitation is Vader itself, not the classifier. In conclusion, Vader does align with star ratings, but only moderately. It captures broad sentiment direction, but fails in sarcasm, neutrality, or more complex reviews. Our dataset also had limitations, mainly polarization from only using high and low rated movies and removing a difficult to clean dataset. Future work should include mid-range ratings, more advanced NLP models, and more robust classifiers to better capture the complexity of film reviews.